Hello guys, so welcome back to the session, that is questionnaire session. So yesterday we stopped with some question, so the same question paper will continue here. So the next question is, a body is projected from the earth's surface with a speed root 5 times the escape speed, that is VE, escape velocity. Yes, let me take a pen. Yeah, the speed of a body when it escapes from the gravitational influence of the earth is, okay, first I'll write the given terms, whatever given in the equation. So initial velocity is nothing but root 5 times the escape velocity. It means it has more energy to go, right? Like root 5 times the velocity, no, escape velocity. So I need to find the speed of a body when it escapes from the gravitational influence of the earth. So I can use the concept, no, like initial energy equals to the final energy. Okay, first let me find what is the initial energy of the given question. So initial energy is nothing but like of m VE square minus the potential energy G capital M small m by R. Okay, this is the initial energy. I'll write it here. So initial energy. So like this normal velocity, right? Root, yeah. So initially it was the velocity. Now if I substitute the value of V, no, it is half m VE square root 5 of m root 5 VE the whole square minus capital M, G capital M small m by R. In this case what I will get? Root 5 into root 5, 5 VE square. So 5 by 2 m VE square minus G m by R. This is the thing of the initial velocity. And one more thing, we know that VE square is nothing but 2 G m by R, right? Like escape velocity formula. So in this, can I rewrite, can I rearrange this one? Can I multiply here m and here m, right? And I can take this 2 here, no? It will be 2 of m VE square equals to G capital M small m by R. Yes or no? Like I can rearrange this one, like can be cancelled, and if I take the 2, again the same formula. So for this G by R, can I substitute the value? 5 by 2 m VE square minus of m VE square. So from this 2 is like in the denominator 2 is same, so I can subtract it, 4 m VE square by 2, which is nothing but 2 m VE square. This is the initial energy. I will write this. So 2 m VE square. The final energy is of mv square. No, this is the final energy, right? So in this m cancelled, and then if I take this to this side, no, it will be 4 VE square, which is equals to V square. So V is nothing but 2 VE. So the escape, like the speed required is 2 VE to escape from the gravitational influence of the earth's surface. Right. If it's clear, we can go for the next question. Okay, can we go? What is the next question given? Yes, a metal rod of area of cross section 3 centimeter square is stretched along its length by applying a force 9 into 10 power 4 Newton. If the Young's modulus of the material is 2 into 10 power 11 Newton per meter square, the energy stored per unit volume in the stretched rod is. Okay. Look at this question once and write the given terms first. Okay. What are the given terms here? Area of cross section A is given 3 centimeter square, no, like into 10 power minus 4 meter square. Then length force is applied, that is F is equals to 9 into 10 power 4 Newton. Okay. Then the Young's modulus Y is equals to 2 into 10 power 11 Newton per meter square. This is the given terms. I need to find the energy stored per unit volume. Like we know the formula, no, U is equals to, direct formula, no, half into stress square by Young's modulus. I will write only Y, okay, Young's modulus. What is stress? What is force by area, right? Stress is equals to, I will write stress is equals to force by area. Like force is given 9 into 10 power 4 and area is 3 into 10 power minus 4. 9 into 10 power 4 divided by 3 into 10 power minus 4, which is nothing but 3 get cancelled and then 4 goes up, no. So 3 into 10 power 8. This is the thing for stress, 3 into 10 power 8. So half into 3 into 10 power 8 the whole square divided by the Young's modulus, which is nothing but 2 into 10 power 11. So if you calculate this one, you will get the energy stored per unit volume, right? Give the answer for the question. Do the calculation, guys. Three, 3, 9, then 10 power 16 will be there, and then 2 to 4, 10 power 11, right? So this one will be 9 into 10 power 10, 8, no, 16, no, yeah, divide by 4 into 10 power 11. So I can say that 9 by 4 into 10 power 5. So the final answer will be yours. Calculation part is yours. Okay, calculate it first. So if you have calculated, give the answer in the comment boxes, guys. Okay, if you have completed, we can go for the next question. Okay. So this question is, answer is 2.25 into 10 power 5. Okay, and the next question. Yes, an air bubble rises from the bottom to the top of a water tank in which the temperature of water is uniform. The surface area of the bubble at the top of the tank is 125% more than its surface area at the bottom of the tank. If the atmospheric pressure is equal to the pressure of 10-meter water column, then the depth of the water in the tank is, okay. So one thing I have understood, I need to find the depth of the tank, right? Okay, we'll find it. First write it. What are the given terms here? The surface area of a bubble at the top of a tank is 125% more than its surface area at the bottom, right? So area at top which is equals to area at bottom plus 1.25, no, 125%, no, 1.25 area at the bottom, right? This is the given term, like 125% more than its surface area at the bottom of the tank. So from this I can write A bottom can be taken out commonly, which is 1 plus 1.25, which is nothing but 2.25, right? 2.25. So A top by A bottom, this is the ratio. This one I will keep as it is. Now we can use the concept, no, like PV, like P is direct, P1 V1 equals to P2 V2, pressure at bottom and top, right, and volume. So next what I can do, one more thing, I need to find the volume, right? Area we know, I need to find the volume. We know that for the bubble, volume is directly proportional to surface area power 3 by 2, surface area power 3 by 2. So V top by V bottom is directly proportional to A top by A bottom, because why I have written V top by V bottom and A top by A bottom? I know the value of A top by A bottom, no, like area of the top and area of the bottom, it is in the ratio of 2.25 by 1. So this is power 3 by 2. I can write directly 2.25 power 3 by 2. I will get the value for V top by V bottom, right? After this what I should do, pressure at top I need to find and pressure at bottom, like I will erase this brush, wait a minute, I will clean it, yes. Yeah, the thing we know that V top by V bottom is equals to or directly proportional to 2.25 power 3 by 2. This one we know. Now for top and bottom, no. So for top it is rho g h, rho g, for bottom I will write rho g h plus what I should do, pressure at the top also I need to, like atmospheric pressure I should write, no, like this, if I take this one, no, this is the tank, atmospheric pressure will be there, at bottom it is rho g h, no, so atmospheric pressure, right, which is equals to top, right, top part, this is the equation. So pressure, atmospheric pressure into volume, right, this one, yeah. So atmospheric pressure into the volume. So which is the volume here? Volume of the top, no, top, and here volume at bottom, that's it. This is the total pressure for the bottom and the volume, the pressure for the up and the volume. So I can take the ratios now here. So rho g h plus P atmospheric is equals to P atmospheric, which is nothing but V top by V bottom, right. You will get some value here, substitute the value in this equation and then take this P atmospheric to the left side, I mean right side, and we know that it is rho g, no, rho g. So rho g will get cancelled and we can find the value of h here. This is the final answer we will get, right. So calculate it first, we will go for the next question. Okay. So answer is given here, it is 23.75. So once you calculate it, cross check it. We'll go for the next question. Yes. If W1 is the work done in increasing the radius of a soap bubble from R to 2R, and W2 is the work done in increasing the radius of the soap bubble from 2R to 3R, then what is the ratio of W1 is to W2? Okay. So work done to increase the radius of the soap bubble, like we know the direct formula, no? W is equals to 8 pi T R2 square minus R1 square. This is the formula, right? So for W1, work done 1, which is equals to 8 pi T R2, that is 2R, no? 2RB whole square minus R square. So I'll get 8 pi T. So 2R square is nothing but 4R square minus R square, which is nothing but 8 pi T into 3R square. This is about work done 1. So work done 2. Similarly, 8 pi T into like 2R to 3R, radius has been increased. So the final radius is 3R, the whole square minus initial radius 2R square. So 8 pi T into 9R square minus 4R square, which is nothing but 8 pi T 5R square. I need the ratio for W1 and W2, which is nothing but W1 by W2, which is equals to 8 pi T into 3R square divided by 8 pi T into 5R square. So 8 pi T cancel, R square will be cancelled. So 3 by 5 is the final answer for this question. Yes, 3 by 5 is the answer. Okay, can we go for the next question? Okay. To increase the length of a metal rod by 0.4 percentage, the temperature of a rod is to be increased. Okay. So the concept, we know that, no, like if temperature increases, let me consider this is the rod, okay, this is the rod. If I increase the temperature, no, the length of the rod also increases, right? So increase the length of a metal rod by 0.4 percentage. So what we can write, delta L by L is equals to 0.4 divided by 100, which is nothing but 0.004. This is about the length of a, change in length of a rod. We know that change in length by length is directly proportional to change in temperature by temperature. Like if temperature increases, length increases. So to remove the proportionality, we add a constant now is equals to alpha delta T. So alpha is nothing but coefficient of linear expansion. Okay, coefficient of linear expansion. So alpha, beta, gamma will be there. So volume expansion and area expansion also is there. Okay. So we are talking about the linear expansion, where we know that delta L by L, it is 0.04, 0.004, and the coefficient of linear expansion is given for the metal. Okay, it is 20 into 10 power minus 6 degree, degree Celsius inverse, right? Yeah. What is this? 0.004 is equals to 20 into 10 power minus 6 into delta T by T. Okay, I need to find delta T by T, which is equals to 0.004 divided by 20 into 10 power minus 6, right? So from this I can say that 4 divided by 20, 10 power 6, this 1, 2, 3, no? So into 10 power 3. That's it, no? Yeah. So you can find the final answer for this. That's the temperature, right? So 10, 4 divided by 2 into 10 power 2. 2 to cancel. This 2 times 200 Kelvin is the temperature. This is about the question. Yeah, answer is 200. You can take it down. We'll go for the next question. Okay. Yes. The power of refrigerator that can make 15 kg of ice at 0 degree Celsius from water at 30 degree Celsius in 1 hour. Okay. What is the given terms we will write here? The given terms is 15 kg of ice, m is equals to 15 kg. So from the 0 degree to 30 degree Celsius, right? So change in temperature 30 degree, right? 30 minus 0, 30, right? And then from water, okay. So I need to find the Q, right? Q. First, initially I need to find the Q for water and Q for ice also. Let me consider this is Q1 and this is Q2. So Q1 plus Q2. So what is Q1? For ice it is, sorry, Q1, right? M into L. What is L? Latent heat, no? So latent heat of ice, which is nothing but 3.3 into 10 power 5, right? For water it is 4200. 4200. I'll write it here. Specific heat of water, like when you are doing the formula for Q2, it is MC delta T, right? MC delta T. M, that is 15 into 4200 into 30. Here it is into 15, right? Mass and the latent heat. I will write it here, latent heat also. L is equals to 3.3 into 10 power 5. So when you calculate Q1 and when you calculate Q2, no, you can add the heat, like how much it has been given, Q1 and Q2. Now I need to find the power, right? What is power? Power is equals to work done by time or energy by time, no? So energy is Q, right? The total energy, Q. So Q by the time is given, which is nothing but 1 hour, no? 1 hour should be considered as 60 minutes and 1 minute is equals to 60 seconds, no? 60 into 60, which is nothing but 3600. So divide by 3600. So calculate Q1, Q2, add them, you will get Q. So Q by 3600, you will get the power. This is the answer for the given question. This is how we will do the question. We'll go for the next question. Yes. So the answer for the given question is 1925 watt. So once you complete it, you can cross check it. Okay, first we'll read the question here. 3 moles of an ideal gas undergoes a cyclic process ABCA as shown in the given figure. The pressure, volume and absolute temperature at point A, B, C are respectively T1, V1, T1 for A, and B is P2, V3, V1, T1. For C is P2, V1, T2. Then the total work done in the cyclic of ABC is, okay, first let me take this one. How many moles has been given? 3 moles, no? Okay. I will write here. First thing, ABC is the cyclic process, no? A, B, C, A is cyclic process. And then A is given as P1, V1, T1, yes. B is given P2, 3V1, T1. C, it is P2, V1, T2. First I need to identify what is the process in AB, BC and CA. Then I can do the work, like, so each process, like if it is isochoric or isobaric or isothermal, each of them have different work done formula, no? So direct work done formula is there. So if I identify the process in AB, BC and CA, I can directly substitute the values there, right? So first I will identify the process AB process. If I see here, temperature is constant, no? Temperature is constant. One thing I can say is as isothermal. Temperature is constant. And if I see here, no, volume changes, no? So volume is expanding, V1 to 3V1. So isothermal expansion it is. AB process is isothermal expansion. Similarly, find for BC and CA. You will get work done WAB and then WBC and then WCA. You can substitute the value and you will get the answer. First you need to find the process for BC and CA, then work done formula you can directly apply. So isothermal work done isothermal expansion work done formula, then what is the process for BC, the work done formula, and process for CA, that work done formula, right? I will show you the options also for this question. Once you can know, take a screenshot of this or note down. There is the options. So we will go for the next question. Okay. The question is given: the pressure of a mixture of 64 gram of oxygen, 28 gram of nitrogen and 132 gram of carbon dioxide gas in a closed vessel is P. Under isothermal condition, if entire oxygen is removed from the vessel, the pressure of mixture of remaining two gases. So remaining two gases is nitrogen and carbon dioxide. I need to find the pressure. No, first what are the given here? Like O2 is given 64 gram. No, so 64 gram is given. So for O2, no, it is the value is 32 gram, mole per gram, no? Mole per gram or gram per mole? It is gram per mole? Yeah, gram per mole, right? Yes. Then for nitrogen, no? It is 28, no? 28 gram per mole. It is 64. The given terms I will write here. Nitrogen, it is 28 gram. Carbon dioxide, it is 132 gram. So for CO2, which is 44 gram per mole. So each of them I should calculate. No, in terms of moles. I know the formula, no, like pressure is directly proportional to number of moles. So I can find the moles, I can say the pressure, no, I can find the pressure. So for this, 64 divided by 32, which is nothing but 2 moles for oxygen, and then 28 divided by 28 is nothing but 1 mole, and then CO2 132 divided by 44, which is nothing but 3 moles. So initially the total number of moles was 6, right? 6. 2 plus 1 plus 3. Am I correct? Yeah. Now oxygen has been removed. Oxygen has been removed. That means the only 2 moles has been removed. So removed in the sense 1 plus 3, that is 4 moles was remaining. So P is equals to N by P dash equals to N dash, right? Or let me take like this. P dash by P is equals to N dash by N. Sorry, N dash by N, no? So what is the final mole? It is 4. Initially it is 6. P dash into P. So 2 by 3. 2 by 3 P is the answer. This is the pressure, remaining pressure, guys. Okay. So with this we'll stop here, and then we'll continue with the next part of the questions in tomorrow's class. Okay. Yeah, fine. Bye guys.